5-7, we're going to start talking about the division of polynomials. Let's go through a couple definitions and notes here that they've provided for you. Dividing a polynomial, now polynomial means it can be one term, it can be two terms, it can be multiple terms. That's what it says, poly, by a monomial. If A, B, and C are polynomials such that C is not equal to 0, then you can simply take the top that is being added or subtracted and break it apart and divide each one of them by that denominator C. And like I said, here is the subtraction, and of course notice they keep the subtraction symbol in between them. Note, to divide a polynomial by a monomial, divide each individual term in the polynomial by the divisor and simplify the result. So let's do that right here with number 1. We're just going to break it apart. I will have 4x to the 4th divided by a negative 2 plus 8x squared divided by a negative 2 minus 2 divided by a negative 2. All right, so we've already done this earlier in the module. 4 divided by, these are just two numbers, just a fraction. 4 divided by negative 2 is negative 2, or you could say negative 2 over 1 if you wanted to. And then there is nowhere for the x to the 4th to go, or to be divided by. See, there's no x term here in the denominator. All right, so I'm going to move on to the next term. Plus 8 divided by negative 2 makes a negative 4. And then I still have nothing to divide that x squared by, so it'll stay there. And then this negative would actually, you can hook it with the 2. It's actually, you could say a negative 2 divided by a negative 2, and that would make a positive 1. So we're just going to clean this up a little bit. These two negatives, a positive and a negative, make a negative, right? If you, in multiplication, opposite signs are negative. 4x squared plus 1. So that would be in simplest form. And so that's dividing by just a real number. So let's come up here to number 2, and let's divide by a variable. Let's see if it's any different. So I'll have, I'm going to break it apart, 7k to the 4th over k squared minus 5k to the 3rd over k squared plus 4k squared over k squared. I've broken it apart. Now, right here, you see the 7 doesn't have, you have just an understood 1 in the bottom, so it's not going to change. But I can do something with the base of k. It have a k to the 4th divided by k squared. And we remember that we can, if they're divided, we can subtract. So k4 minus 2 is k squared. Remember, it's a positive 2, so it stays in the top. And that's where the most are, so that's where my answer would be. Either one of those approaches would work. This is a negative 5 up next. No number on bottom, so it's just going to stay a negative 5. And now I have next to look at is k to the 3rd over k squared. Again, that's divided. So I'll need to subtract. 3 minus 2, is 1. And that will go in the top because it's positive, and or you could say because 3 is greater, that's where I put my remainder. And then finally on the last one, we have just 4 divided by 1, if you'd like to say that. So it's just 4. And k squared divided by k squared, remember 2 minus 2 is 0. So what you're left there with is actually k to the 0. Anything to the 0 power is what? 1. So you'd actually have 4 times 1 there if you'd like to write that. But to put it in the, given as a final answer, to put it in, you don't need to either give this exponent of 1, nor do you need to leave this here. You'll need to go ahead and combine those two. Or do away with this 1 and multiply these two. Okay, number 3, let's look at it when we have both a number and a variable in the denominator. So we're going to divide by both 5y squared on every 1, like so. So starting with the first term here, your leading term, I'm just going to divide. 25 divided by 5 is 5. And then you'll see here that y squared and y squared, you can say they divide out. You can say 2 minus 2. You can, let me write it over here to make a point. Y squared divided by y squared divides and makes 1. You could say y squared is going to be 2 minus 2, which is y to the 0, which is still 1. Either of those approaches get you the same answer. Minus, I now have 10 divided by 5, which will make 2. And now I have, here on the next one, I have y to the first divided by y squared. And let's write this over here. Y to the first divided by y squared. If you wrote it out this way, that's 1 minus 2, which gives you y to the negative 1 power. Well, what do you have to do with that? You can't give that as an answer. You need to make it be a positive exponent. So this would be what I get when I subtract my y values. So I'm going to put y to the first in the denominator over the 2. Now remember, the 2 is not in the denominator. It's 2 over 1, if you'd like to put it that way. All right, and the final term, if you see here, 5 divided by 5 falls out, divides out, makes 1. And there is no y value up here in this denominator to divide or subtract from this y squared, so it simply just stays in the denominator. Now, do I not put anything up there in the numerator? No, you got to put something up there, and that something is 1. You cannot leave an empty numerator. So let's clean this up. 5 minus 2 over y plus 1 over y squared. And finally, number 4, we have just appears to be multiple variables, x and y. A trinomial here, and we're going to divide it by the same x and y. Now you want to be careful that you don't lose any signs. You want to just check and double check that you've wrote your problem down correctly and you have the signs in the correct place. All right, starting off with the first term, I first see double negatives. That's the first thing on here. So negative divided by negative makes a positive. Moving on to the x terms. Now, if you'd like to separate these, we did this earlier. You're welcome to do that, to put some space in there. But I'm going to subtract. That is actually going to be x to the 3 minus 2, which makes x to the first. So it will remain in the numerator. So I have x to the first. And then if I look at my y terms, I have y to the first 1 minus 2, which is y to the negative 1. So it's going to have to go to the bottom so it can be positive. All right, moving on to the next set. Again, I see double negatives here. All right, looking at my x's. So if you just look at the x's, you have x squared divided by x squared. They divide out. Or so you can say 2 minus 2 makes x to the 0, which is again 1. So far I've got a positive 1. And then I've got, again, notice this is 2 minus 2, or you can say same terms divide out. So I just have a positive 1 there. You could put it over 1 if you wanted to hold the position till we get through going through these. Then I have double negatives make a positive. All right, so I have an x here. Let me come down here and put my positive. So that's x to the first minus 2, which is x to the negative 1, which means I have to put it in the denominator. All right, take care of that. And then finally with the y's, I have y to the 3 minus 2, which is y to the first. It's positive, so it gets to remain in the numerator. So let's just kind of clean this up. X to the first over y plus 1 plus y over x. Now, or you could see, sometimes you might see them put the variables first and always put the constant at the end. Either way should be just fine for you to enter in as an answer. Now we're going to talk about long division. So if you're dividing your divisor has two or more terms, a long division process similar to the division of real numbers is used. The solution to a long division problem is written in the form you have your quotient plus your remainder of your divisor. Now, here's a tip. Recall long division is used when the divisor has two or more terms. If the divisor has one term, then divide each term in the dividend by the monomial divisor. That's kind of what we did before. So let me just remind you of a few steps before we dive off into this. Suppose I have, think way back, 4 into 679. Remember doing this? And what did you have to say? Okay, can 4 go into 6? Yes, 4 times 1. Because 4 times 2 is 8. It's too big, so you back up and do 4 times 1. Okay, then when we come around this way, what did we do? We multiplied, right? 1 times 4 is, and you wrote it under that number. And then at this point, what did you do right here at this point? You subtracted. Well, basically, see, that's a positive 4. You're doing a sign change. You're multiplying by a negative. And so then we subtracted and got, okay, 6 minus 4 is 2. And what do we have to do in the next process? Bring down why did you bring down a 7? Well, because 2 is too small for 4 to divide. There's not enough there. So you bring down the 7. Okay, then you say, what number can you multiply 4 by that gets you closest to 27 but not over? 4 times 6 is 24. 4 times 7 is 28. So we'd have to go by 6. And then you said, what did we do coming around this way? We multiplied. 6 times 4 is 24. When we put it here, what did we do? A sign change. We subtracted. And that made 3. And then we brought down our last number. And we said, okay, 4 times what gets you closest to 39 but not over? 4 times 9. 9 times 4 is 36. And we subtracted, sign changed, and we've got 3. Now, at this point, of course, I know, remember, you could put the decimal and put a bunch of zeros, but let's just stop it right here. What would your answer have been at this point? Do you remember? It would have been your quotient, 169. And remember making a fraction? Okay, you took your remainder divided by your divisor. And so remember coming over here and saying, okay, it was 169 and 3. Wrong pen, excuse me. See, 169 and 3 fourths. And so this time, and that's the same as saying 169 plus 3 fourths. See, we're going to put a plus sign in there. It's the same thing. And in fact, if you were going to put this in your calculator, you wouldn't put that in there. You would have to put this in to get the correct amount entered into your calculator. So we're going to do this same process here. Exact same process. We're going to do sign changes. We're going to bring down numbers. And this is exactly how we're going to write our answer. So keep this in mind as we come over here, and let's now look at number 5. So the first thing we're going to do is put this, is what comes, they used to tell you on the outside. It's called your, let's go back up here and look. It's called your divisor. All right, so we're going to put our divisor out here. And we're going to put the other inside the house, they used to tell you. All right, so let's look at it. What I want you to do is, in a sense, you're going to just, when you're trying to decide what to multiply by, you almost ignore that second number. You're going to focus solely on this first leading term here. And you're going to look at your first term with the first term here. Okay, so we're just going to kind of ignore 8 for right now. All right, you have 1c here on the outside, and I need to make it become c squared. What do I multiply times c so that it becomes c squared? C, right? 1c and 1c makes c squared. So that's what I'm going to multiply by up here. By 1, and we're going to move it, since there's 2 terms here, we're going to skip down and put it on the second term. All right, so c. Now, when you come back across here, remember we multiplied. Go back and look at our example. We multiplied. But now you got 2 terms to multiply it to. So c times c is c squared, and c times 8 is 8c. Now, remember what we did right here? we did a sign change. We subtracted, which if you're going to subtract this one or give this one a negative, you've got to give the other one term a negative as well. And this should zero out. You should get a 0 there. We did. That means you did it correctly. So 6 minus 8 is negative 2c. All right, how many terms are back over here? What we're dividing by? There's 2. So that tells me I've got to have a second term, and I do have a second term I can use, so I'll bring it down. Now, here's what you're dividing by, c. What can I multiply c by so that I end up with this one? Oops, this one. I need a negative 2c. So what are you missing? What have you got to multiply by? Negative 2. That's what I need to multiply by. So that is what you're going to come up here and multiply by. All right, coming back around again, you're going to multiply to both parts. So negative 2 times c is negative 2c. And negative 2 times 8 is negative 16. But when you draw this line, what are you supposed to do? Sign change. Subtract. So if I'm going to subtract here, this is going to be, basically I'm going to distribute a negative to everybody. So I like to just go ahead, instead of putting it out here, I just like to go ahead and change that sign and change that sign and be done with it. So this zeroes out like it's supposed to. And here I have left negative 2. So how are we going to write our answer? It is your quotient. So my answer is c minus 2 plus the remainder. What was your remainder down here? Negative 2. Negative 2 divided by, what is your divisor? C plus 8. And that, my friend, is your answer. All right, let's come over here and look at part B. Check by multiplying the quotient by the divisor and adding the remainder. So let's go back and look at what we did up here. We had the answer 169 3/4. Now what they want us to do is multiply these back together. So if I come over here and say, all right, what's 169 times 4? That's 36, carry my 3, 24, and 3 is 27, carry my 2, that's 676. And they want me to add the remainder. And so 676 plus 3 is 679. Is that what we were originally dividing? Yes, it is. So let's come back down here and look. That's what they want us to do. So if I take, now my answer, remember, is c minus 2 plus a negative 2 over c plus 8. So if I multiply the divisor and the quotient, here's the quotient and the divisor. If I'm going to multiply these two, let's come over here and do c minus 2 times c plus 8. That's going to be c squared. That's going to be plus 8c. It's going to be negative 2c. And it's going to be negative 16. And then they want me to add in the remainder. And my remainder is negative 2. I'm going to say plus a negative 2 or just a negative 2. So that's c squared plus 6c. And this makes what? Negative 18. Now, go back and look. Is this what they asked us to first divide? Yes, it is. It's kind of a mess up here with all my arrows. But if I can erase some of that out, look at there. It's the exact same thing they asked us to divide. All right, so they asked us to divide. I want you to notice this is a binomial. It's not just a single monomial like we did on the other page. So that tells me I'm going to have to do long division. So I'm going to put y plus 1 on the outside. And I will put the numerator inside the house. Now, later on, we're going to learn another way to kind of do this called factoring, where you factor it out. But for now, we haven't got there. So our only tool right now is to do long division. So let's go through the whole steps again. I'm going to be looking at just the y, and I'm going to take the first term. I have y. I need to multiply by something to get y squared. What would that need to be? A y, right? 1 times 1 makes 2 of them. So I'm going to multiply by y, and I'll put it over the second term because there's two terms here. I'll need to skip down to the second term. And then coming back around, I'm going to multiply. Remember, you multiply by both of them. Let's shift this down here. Get this out of our way. All right. Y times y is y squared, and y times 1 is 1y. Now remember, at this point, when you draw the line, you're going to be subtracting, sign changing, sign changing. And your first term should zero out, and it does. And so here we have a negative 3y. Your divisor is two terms, so you need to have two terms down here to continue. And so I do have a term I can bring down. That's going to be positive 3. So here's what you're going to think. I have y in the divisor. So y times what's going to give me negative 3y. We already have the y. I need to multiply by negative 3. So that's what I'm going to put up here is the negative 3. Coming back around, got to multiply it to everybody. So that's going to be negative 3y and a negative 3. What do you do at this point when you draw the line? You subtract, which is a sign change and a sign change. The first term zeroes out. The second term gives you 3 plus 3, which is 6. So to write your answer, you're going to have the quotient, y minus 3, plus the remainder, 6, divided by your divisor, which is y plus 1. And again, if you wanted to check yourself, look at the example above, you would remultiply the divisor by the quotient and then add to it your remainder. Number 7. All right. 3w plus 2 is our divisor. 6w squared plus w minus 2 go in the house. All right. So we've got two terms. I'll look at the 3w and the 6w squared. So you're thinking, what do I multiply times 3w to get 6w squared? Well, I've got to say 3 times 2 to get 6, and I've got to say w and another w to get w squared. So I'll end up multiplying by 2w. Coming on back around, 2w times 3w is 6w squared, and 2w times 2 is 4w. We now have to sign change and sign change, subtract and subtract. And looking at it, I see that the 6's do zero out like we're expecting them to. Negative 4w plus w is negative 3w. I need two terms, so I will bring down the remaining negative 2. I have 3w. What am I going to multiply it by to get negative 3w? What's the only thing different? The negative. So that's what you'll have to multiply by. So I'm going to multiply by negative 1. All right, multiply coming around. Negative 1 times 3w is negative 3w. Negative 1 times 2 is negative 2. All right, here we're going to do sign change, sign change. And so this will 0 and this will 0. And so you're just left with the answer of 2w minus 1. Now, what this means is when you actually have a remainder of 0, we'll call this, later we'll talk about it, but it's a factor. It's actually a factor of this trinomial is 2w minus 1 and 3w minus 2. And of course, if you want to check yourself, all you got to do is multiply 3w plus 2 times 2w minus 1. And you should end back up with what we started with. And if I just do a real quick little check over here, I do end up with the original problem. Okay, we just have some more examples here to go through. 2x plus 3, and in the house we'll put 2x to the third, plus 3x squared minus 2x plus 5. Now, we have not discussed this, and I'm sure it'll come up somewhere along the way, but let's go ahead and just talk about it right now. If your dividend, what you put in the house, this right here, has multiple terms, you need to make sure of a couple things. One of them being they need to be in descending order. All right, the next thing you want to make sure of, number 2, is there are no, and we'll just say missing pieces. For example, if you start with, let's just say, x to the 5th, then you need to have a piece for the 4th power, the 3rd power, the square term, the linear term, and then you can put a 0 in there for your constant as well. So what I'm trying to get at is usually what would happen, they'll give you, say, x to the 5th, and they'll give you a constant in here of 4. Well, you can't just put x to the 5th plus 4 inside the house here. You're going to have a 0, and I like to even, put my exponents on there just to keep it hold the place. But you've got to put a 0 in there to hold the place of whatever is missing. If there's one missing piece or 2, and we'll have maybe some examples coming up where I can show you this. But you want no missing pieces in your descending order. You're going to use zeros to fill in the terms, the missing powers. So let's just look at the first one. It is in order, the 3rd power, 2nd power, 1st power, and the constant. So all that is there like we need it to be. And so we're going to start out by saying, let's shift down here. We start with what? 2x. And what do we need to multiply to get what? 2x to the 3rd. So what's missing? I have 1 here. I'm going to 3, so I need to multiply by x squared. So that's what I'll put up here. By the 2nd term, I'm going to put x squared. So coming around, remember you come around, you got to multiply to both parts. So that's going to be x squared times 2x is going to make 2x to the 3rd. And x squared times the 3 is going to make a positive 3x squared. All right, so at this point, what do? Sign change, sign change. So this zeroes out like we were expecting. But we were not expecting this. 3x squared minus 3x squared also zeroes out. So what do we do now? Well, you got to bring one of them down. Is that going to be enough? How many pieces are over here? How many pieces are we working with over here? 2 pieces. So I've got to go ahead and bring down the last term. I've got to have 2 pieces in order to continue. So I've got, starting out here, I've got 2x. What am I trying to get to? This term, negative 2x. What am I going to multiply by? What's missing? A negative 1. If I multiply by a negative 1, it'll give me what I'm looking for. So up here, I'm going to multiply by a negative 1. Negative 1 times negative 2, coming back around now. I'm multiplying. Stay with me. Coming back around and multiplying. So that's going to give me negative 1 times 2 is negative 2. And negative 1 times 3 is negative 3. At this point, we do sign change and sign change. Multiply by a negative. Subtract, however you want to say it. This makes 0, and at this point I have 8. So my answer for this would be x squared minus 1 plus the remainder divided by the divisor. Now, some people have asked me before, why don't I put a 0 since this zeroed out and I didn't use this term? Shouldn't I have put a 0 up here? Well, you could have. But in the end, you're still going to remove the 0. It doesn't really do anything but maybe hold a space that you're going to eliminate anyway. So it's not really necessary to put a 0 up there. You can simply just move on to the next term. All right, number 9. So I'll have 3m minus 5. And the dividend would be 6m to the 3rd minus m squared. Okay, I'm noticing, and I didn't say anything, but I'm noticing that I am going I am descending, but I see I am missing a term. What are you missing? You're missing to the first power, the linear term. So you want to put a placeholder in there when you're actually doing the computing and the dividing. And now I can put my constant. So going down, 3, 2, 1, none. So I'm good. I can get started now. All right, so what have I got? 3m. I got to multiply it by something to get what? 6m to the third. Well, 3 times 2 will give me 6. And m1 means I'm going to need 2 more to make 3. So that's what I'll multiply by. 2m squared. All right, what do? Coming back around. 2m times 6, 2 times 3 is 6. And 2 plus 1 makes 3. And then 2 times negative 5 is negative 10, m squared. This is the spot where I do subtract, sign change. This makes 0 like I was expecting. So now I have positive 10 minus 1 makes 9m squared. Bring down the next term. And I've got to say, all right, I'm starting with 3m. What am I going to multiply it by to get 9m squared? Well, I'm going to have to say 3 times 3 to get 9, and 1m plus 1 more makes m squared. So that's what I'll multiply it by up here. It's a positive 3m. All right, coming back around to multiply with it. I'm going to have 3m times 3m is 9m squared, like I was wanting. 3m times negative 5 is negative 15m. This is where I change the sign. This makes 0 like I'm expecting. And now you see you have 0m plus 15 makes 15m. I need 2 parts, so I'll bring down my final piece. And now I'm looking at 3m being multiplied by something to make this, 15m. Well, 3 times 5 makes 15, and I only need 1m, and I have that, so that's all I multiply by is this 5. Coming back around, you'll have 15m minus 25. At this point, change the sign. This makes 0, and right here I have a positive 22. So what is your answer? 2m squared plus 3m plus 5 plus 22, the remainder, divided by the divisor. Okay, one last problem on this page. I'm going to put y squared minus 5 on the outside. And looking at what goes on the inside, the dividend, I'm reminded of 2 things. It has to be in descending order, and I'm reminded that to look for any missing terms. So, the leading power is the 4th power, so it's going to go first, and that means I'm missing y to the 3rd. I do have a square term. I do not have a linear term, but I do have a constant. All right. I'm starting off with a y squared. So what do I do to y squared so that I get, when I'm going to multiply by it, so that I end up with y to the 4th? Well, I just need to add 2 to that, an exponent of 2. So that's what I'm going to multiply by. So I'm going to say y squared. Coming back around, that's what I'll multiply each term by. And I end up with y to the 4th minus 5y squared. All right, so just hang with me. So we're going to change the sign. So I end up here with 7y squared. Now, even though this was a 5y squared, I put it in line with the other y squared. I want you to notice that. I had to put it with these like terms here. So it means I kind of skipped over this 0y to the cube. I didn't need the 0y cubed to keep my problem in order so that it would line up correctly, and that's okay. So what I'm going to do is come over here to the next one, and I'm going to bring down the next term, which is, in fact, a 0y. Well, let's just see how it plays out. Probably because this 5 over here doesn't have a y on it, that it won't really be necessary, but let's just see what happens. All right, so I have, like before, I have a y squared, and I need to know what do I multiply by to get 7y squared. All right, well, that just needs a 7. So that's what I'm going to come up here and multiply by. All right, so 7 times y squared is 7y squared, and 7 times negative 5 is negative 35. See, it won't even come into play with this 0y. It's actually, I needed to bring down the negative 29 so that I can put the negative 35 with it. It didn't, like I had predicted before, because that 5 didn't have a y on it, I wasn't actually going to use the 0y. Now, does this mean I don't have to put the zeros in there? Absolutely not. You've got to account for your spaces because there are going to be times when you do need them. And if you don't have them in place, you're not going to have a way to line it up and keep your numbers going in order. This is just one of those cases where you didn't have to have it. Okay, so my final answer, y squared plus 7 plus 6 over y squared minus 5. So number 11 just asks you to kind of recap. There are 2 methods for dividing polynomials. When is long division necessary? So let me just show you an example. 6x to the 4th plus 3x squared minus 11 over, let's just say x squared, versus 6x to the 4th plus 3x squared minus 11 over x squared minus 1. Which one of these would require long division? When is long division necessary? It is necessary when you're dividing by something other than a monomial. If it's a monomial, you can split it into 3 separate fractions. If it is anything but a monomial, you're going to be required to do long division. So here on this page, they're going to ask us to use what we just talked about with number 11. Determine which method to use to divide the polynomials. Monomial division or long division. And then we're going to use that method to divide the polynomials. So look at number 12. What is in your denominator? It's a monomial. So we do not have to do long division. We're simply going to split them, divide each term in the numerator by the denominator. And then you can just go through the process of dividing. First, I'll divide this fraction. 4 divided by 2 is 2, or 2 over 1, if it helps you to write that. And then I'll look at the base of a. I have a to the 5th minus a to the 1st. They're divided, so you subtract. And so that leaves me with a to the 4th, which would remain in the numerator because it's positive. Minus, next fraction, 8 divided by 2. That's 4. And then I have a to the 3rd minus 1. A to the 3 minus 1, because they're divided, you subtract, you get a squared. That's positive, so it will remain in the numerator. Plus, well, here I see 2 divided by 2 is 1. A divided by a is 1. So this all divides just to make 1. 13. This is what you're dividing by. It's not a monomial. So I have to do long division. So in the house, I'm going to put 8 into the 3rd. And then I see the square term is missing, the linear term is missing, and I do have a constant. I want to put them in there in case I end up needing them. Okay, so I'm looking at 2n, and I need to multiply it by something to get 8n to the 3rd. Well, that's going to be 2 times 4, and that's going to be n squared. You got 1, you need 2 more to make 3. So that's what I'm going to multiply by is 4n squared. All right, so coming back around, remember you got to multiply by both parts. I end up with 8 n to the third minus 12. See, 4 times 3 is negative 12 n squared. Well, look at here. I do need that 0, negative 12 n squared, so that my columns will line up with the correct like terms. All right, subtract, subtract. This zeroes out as I was expecting, and this is 12 n squared. I'm just going to go ahead and bring down the 0 n. So let's see. I'm starting with 2n. I got to multiply it by something to now get 12 n squared. Well, I know that's got to be multiplied by 6, and I'll need one more n. So up here we have 6 n to the first. Coming back around, I have 6 times 2 is 12 n squared, and 6 times negative 3 is negative 18 n. Look at there. I did need that 0 n. Sign change, sign change. Zeroes out, and this gives me 18 n. Bring down my last term, negative 27. All right, so I'm starting with 2n. I got to multiply it by something to now get 18n. So all this time I need is a 9. So I'll multiply by 9. And coming around with the multiplication, I'll have 9 times 2n is 18n. 9 times negative 3 is negative 27. Subtract, sign change, sign change. This zeroes out, and this zeroes out. So my answer would be 4n squared plus 6n plus 9. This is a factor of the original, 2n minus 3 is a factor of 8n to the third minus 27. They're both factors because you have a remainder of 0. 14. Well, it is not a monomial, it's a binomial. So we're going to have to do long division. H squared plus 3. And the dividend, that is correct, but I'm missing an h to the third. I have an h squared. I'm missing the linear term, but I do have the constant. All right. I have, let's shift over here, I have h squared. What am I going to multiply by to get h to the fourth? I'm going to multiply it by h squared. 2 and 2 makes 4. So that's what I'm going to multiply by over here, h squared. And so you remember when we come around, we're going to multiply it to both parts. And so that's going to give me h squared plus, now this when you come around gives you 3h squared. That will not go in this column. It's going to have to, so we're actually not going to use this column. We're going to have to put it down here with the square term. So change it, zeroes out like we were expecting. And this is negative 1h squared. I'm going to bring this down. I may not need it, but I'm going to bring it down anyway, just to be sure I have it. So I'm starting with h squared. What am I going to multiply by now to get the negative 1h squared? Well, I'm going to multiply by negative 1. That's all that's missing. So negative 1 on top. We're going to bring it back around. And we have negative 1h squared. And then negative 1 times 3 is negative 3. Well, I don't need that with this linear term here, so I won't be using that. I'll actually have to bring down the negative 5 so that it actually has somebody to pair with. So once again, I had negative 1 times 3 is a negative 3. At this point, change the sign, and we have this making 0, and this makes a negative 2. So, what is our final answer? H squared minus 1 plus a negative 2 over h squared plus 3. Or you could have said, recognizing that these double negatives would just be minus 2 over h squared plus 3. Final question, long division or not? This is a monomial, So, or no, we're not going to do long division. We're simply going to break it apart into individual fractions and simplify it that way. All right, so here we go. 6 divided by negative 3 is negative 2. 3 minus 2 is 1. Double negatives here make a positive. 4, r squared divides out. 9 divided by negative 3 is negative 3. Now, careful here. 1 from 2. You've got r to the 1 minus 2 makes r to the negative 1, which means it needs to go in the denominator. So this is going to be negative 3 over r to the first power. And then these double negatives make a positive. Those divide out, simply leaving me with 1 over r squared. So I would probably give this as my final answer. You could rearrange it and put the constant at the end. I'm not sure that it would be necessary, but you could.